Hello, good evening. It's Doc Kyle once again, and I congratulate you for being promoted and welcome to Histopath. My topic will be Neoplasia, and it simply means a new growth. Neoplasia can be either benign or malignant, and it is a growth that is uncoordinated with the normal cells within the tissue surrounding it. But it can be also physiologic and pathologic. So we shall begin in giving types of neoplasia. So we have a hypertrophy, the hypertrophy, we have hyperplasia, we have metaplasia, and we have dysplasia. This hypertrophy just means that there is an increased synthesis of proteins within each individual cell. This cell is usually not able to divide. So what it does in order to increase its function is just get bigger. That's what happens in your skeletal tissue fibers. Because they cannot divide, they just produce lots of proteins and make themselves bigger so that they can form stronger contractile function. This occurs when the cells are being challenged, as in your weightlifting, in your exercise. And the next is your hyperplasia. This occurs when your cells can divide. An example of which is a physiologic hyperplasia. Example would be your uh, endometrium when it is undergoing pregnancy. Like I mentioned in the past lectures, that you need lots of glands in your endometrium when pregnancy occurs because it needs to transfer those nutrients to the placenta and to the baby eventually. So it needs to divide and make lots of glands. So a pathologic type of this hyperplasia can be seen in your warts. What happens in your warts is when human papilloma virus infects keratinocyte, it forces it to divide and multiply. So what happens? It makes a bulge of these accelerated divided cells, and that is your hyperplasia, pathologic hyperplasia. That is your wart na. So we will talk about this metaplasia and dysplasia later, but simply put, metaplasia is from a squamous cell, example of which is from a squamous cell to a columnar cell. It transforms, no, meta meaning to another. So it transforms from one type of cell to another. And then this dysplasia simply means this meaning disordered, meaning if I were a cuboidal cell and my 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 dimensions would be like a hexagon, and my nucleus is supposed to be round but it's now very oblong, then there's disordered growth. So we can attribute it to dysplasia. But all of these things, this type of neoplasms, aren't essentially malignant per se. There is still a differentiation between benign and malignant, and we will talk about that later. So, oncology, the study of tumors or neoplasms, and as you can see here, I will zoom in. Oops. Here. So, hypoplasia. Hypo meaning decreased or low. So, instead of forming 9 cells, you just make 2. Hypoplasia. That's what happens in your aplastic anemia. Hypoplastic immune cells because of the attack from viruses, chemicals, etc. And then there's hyperplasia, like I said earlier. Hyper meaning increased, plasia meaning synthesis. So hyperplasia, increased synthesis. Neoplasia, similar to hyperplasia but denotes an abnormal multiplication. So this neoplasia is somewhat an all-encompassing term, no? This picture I'm showing you is quite lahi ang pag-present, but more or less neoplastic processes ni sila. So dysplasia, like I said earlier, there is a disordered proliferation, metaplasia, from this columnar, nahimo na siyang stratified cuboidal, stratified squamous rather, and anaplasia. I want you to remember anaplasia. Anaplasia means dedifferentiation. So we will talk about that more later, but simply put, anaplasia meaning ana meaning going back, plasia meaning instead of being a mature cell, what you see in the mass or in the specimen is clumps of immature cells. So we will talk about how that happened. So basic components, there are the neoplastic cells themselves and the reactive stroma. What happens if there is a neoplastic process? It not only involves the cells affected but also the surrounding tissue, the fibrous tissue, because if the neoplastic cells are very they divide rapidly, and they are very voracious eaters. They need lots of nutrients. What happens is they force angiogenesis to make blood vessels, and then they try to make their own supply lines. And eventually, if they don't get the nutrition, they eventually die out. And then at the same time, your immune system is trying to suppress the neoplasia, and then there are the surrounding stroma, the fibrous area, react to that. So there is adaptive and innate immunity na associated with that. And then what happens is the body, if the mass or lump of neoplastic cells divide rapidly, what happens? The surrounding fibrous tissue around them gets crushed, ano? And then this fibroblasts get crushed. They reklamo, tabang, help. And then when they send out these signals, they in turn they proliferate, and then they become thickened. So what happens is your neoplastic processes sometimes, when they grow too fast, when they grow and then they stimulate the fibroblasts go around them, they make these desmoplastic changes, meaning the surrounding tissue around them becomes fibrous in an attempt to localize the mass so that it won't spread more. No, it's trying to constrict the mass while it's early. But sometimes, if it goes through that capsule, then it's gonna be a big problem. Benign tumors are gross and microscopic appearance are relatively innocent, remain localized, will not spread, and amenable to local surgery. Like I said earlier, if the mass is slow growing, then the surrounding tissue, the surrounding fibrous capsule, can grow with it, in a sense that it can grow. The bigger the mass, also the thicker the capsule will be, limiting its further growth. So that's what happens in benign tumors. In benign tumors, their growth is quite slow. And apart from being slow, they elicit a reaction that makes them localized around the capsule. And even though they, apart from that, they don't have the ability to break through that capsule. So, and what happens is the rate of divisions of the cell within the benign mass is relatively slow. So, like I said earlier, this rate of division is very important because this will dictate whether or not the mass is either malignant or benign for most cases. Because malignant tumors, they divide quite rapidly, in a sense that the body cannot compete with the rate of its division. Thus, wala na time ang body to kill it or to contain it. So, most of the times, these malignant tumors, they break free from the capsule. And once they break free from the capsule, it can go anywhere. That's why maabot siya sa liver, sa kidney, but we'll talk about that later pa, no? So your benign tumors, simply put, this is this oma here, the suffix oma, is just a rule of thumb. No, it's not the, I rather it's not the rule. It's not a hard rule. No, so there are some masses like your hepatoma. It's a malignancy gihapon. It's malignant. It's not benign, but most omas are benign. So you have your adenoma. So this is just a mass composed of your glands, your cystadenomas. So adeno. Remember that the adeno is from the Greek word meaning gland. Everything that has a gland, no? So your GI tract, your colon, there's lots of glands there because they produce lots of secretions. Also your nose, it's a gland. Your breast, more or less, it's a gland, apocrine gland, no? So because it secretes milk, mo ba ito yung purpose. Your endometrium, there's lots of glands there to produce the nutrients needed when there is implantation na. And then, kato. So your papillomas, your finger-like or warty projections, papilloma, papillae, meaning fingers in Greek. Cyst adenomas, meaning a cyst is just a simple CYST, is just means a fluid-filled sac. So there are different types of cysts, pseudocysts and true cysts. But simply put, a cyst is just a fluid-filled sac. So just there's a membrane and then there's fluid inside. That's a cyst. Papillary cystadenoma, there are finger-like protrusions within the cyst. This is a cyst. There's finger-like protrusions inside. Then a polyp, neoplasm, no? They are a projection. So, what's the difference between the polyp and the adenoma? In the polyp, in a sense, there is a overgrowth, but there is a fibrous core now. But so, can you say this one is an adenoma versus a polyp? If you're just gonna look at it grossly, pag example, nakakita ka sa imong skin, there's two out of nowhere na two out project mass that project, no, kanang nagburot ba. Can you say that one is a polyp and one is an adenoma? Of course, the lahi man jud because the lining of the skin is different, but for us to differentiate the adenoma from the polyp and the papilloma, we really need to do microscopic evaluation, microscopic examination, no? So this is the crux, no? This is the purpose of histopathology in general, for us to, from the name itself, histopath, histo meaning tissue, patho meaning diseases of the tissue, and oji, study of. We study the tissues, no? That is the main purpose of histopathology, for us to study the specimen given to us by your endoscopists, surgeons, even your pulmonologists, your endocrinologist. It's a mixed bag of specimens that we need to study. So, yun. Voila. So this picture, this is just a gross picture, and this is the microscopic picture. If we're gonna zoom in, we can see this is a mucosal mass measuring maybe 0.5 centimeters, composed of tan flesh-colored finger-like projections. So this is your papilloma. It's finger-like projections. So if you're gonna ask me, Doc, why are some masses different from other masses? What dictates them? And alas, we have come to the crux of the conversation. Everything or anything that happens to your body, well, of course, regardless of kana example ng ligsan ka og truck, no, But the course of your body has already a blueprint. And from the name itself, genetics, genesis, beginning, it will follow that. So if there are any disruptions in your genes, in your DNA, it will eventually lead to some kind of overgrowth, or in some cases, hypoplasia, or like thymic hypoplasia, or in some cases, pod autoimmune disorders. So we will talk about that later in how we can relate genetics to this neoplasms. No? So this is a finger-like projection. This is your papilloma, and this, okay, this is a good showcase on why it is needed. Look over here. This is a colonic mass, maybe measuring about 2 cm. And then if you look over here, this is a single mass pod. So when you're gonna, if ang nahatag lang sa laboratory is, imagine just this little thing here, walay labot ni din eh. And this one just a bite over here. Of course, the people who try to, the people who send a specimen to the laboratory, they try their best to get the entirety of the specimen. But if you were gonna look at them like this on top lang and this one over here, they're gonna look the same grossly. That's why we really need to look at them through the microscope, and we really need history. So example, this one is a colonic mass. So the patient presented with melena, with constipation, with occasional diarrhea, with GI symptoms. So, and then the endoscopist will show us a picture, and then we process it in the lab, and we will see this. So this is a colonic mucosa. This is an adenoma. It's filled up with glands. It's filled up with glands. And this one over here is a polyp, because there is a stalk. Usually a polyp has a fibrovascular core. What does a fibrovascular core mean? Wait lang. So this one is the fibrovascular core. That one, the stalk. And this one over here is a cyst. It's a membrane containing fluid. So, ayun. Next slide. So, malignant tumors or cancers, they are called, when the Greeks first saw it sa una, they named it, like, it looked like a crab. The breast cancer, when it becomes very big, it looks like somewhat a crab. So it can adhere to any part that they seize on in an obstinate matter. So they don't care. So they invade and destroy adjacent tissues and spread to distant sites. So these sarcomas are malignant tumors arising in solid mesenchymal tissues. Leukemias and lymphomas arise from blood-forming cells, and squamous cell, stratified squamous epithelium, adenocarcinoma, grows in a glandular pattern. So, going back. So, what dictates a malignancy? So, where does it all begin? What happens in a malignancy is that, we'll talk about it later na lang, more of it later. So, over here, this is a breast. When you cut it in half, it revealed a tan white mass. So, that is your cancer, breast cancer. It's white, and usually the surrounding area is, like I said earlier, nice stromal reactivity. There is a desmoplastic reaction. So, and then this one over here, like that, you see that? That is your osteosarcoma. That is your bone cancer, no? Ay, bone malignancy. And over here, oh, it's a PBS, peripheral blood smear. But why do I see cells with big nuclei? These are your myeloblasts. No? And then over here, we have your different types of skin cancer. We have your basal cell carcinoma, squamous cell carcinoma, melanoma, and Merkel cell. And then, what is this? There's rugae. Rugae. So this might be this intestine, no? This is your colon cancer. As you can, as we can all see, it's not fun. No, it's really, it's a sad fate to have cancer, and with all the factors that dictate you having or not having cancer, it's really sometimes it's really fate, you know. So the characteristics of benign and malignant neoplasm. So differentiation and anaplasia. So differentiation means if I were a germ cell of the, if I were a super, if I were a germ cell of the squamous cell, no, I would become a keratinized squamous cell. That is my goal. That is my maturity. That is where I'm headed for. But if I don't mature and then I stay germ cell, non-keratinized, same lang gihapon, then that is anaplasia. There is no maturation. There is no endpoint because your specialized cells, they are the one that does the function. So what is the purpose of your squamous cells? The purpose of your squamous cells, no, in the case of your skin, is to protect you. So they need to be keratinized, they need to be flat, they need to have a large surface area. They don't need to divide, they don't need to undergo mitosis if they are the mature ones. So the ones that does the mitosis, are in charge of the mitosis, are the immature keratinocytes, the germ cells. They are the ones in charge of refueling the pool of maturing squamous cells. They are the one in charge. But if what happens, instead of maturing after division of your squamous cell germ cell, instead of undergoing maturation, they just divide and divide and divide and divide, and then they don't undergo any more maturation katong. The nucleus decreases in size, the cytoplasm enlarges, increasing of intracytoplasmic keratin, and then they just divide, and then they divide. What happens? That's what you call anaplasia. They don't undergo differentiation anymore because they are constantly dividing. That is one of the hallmarks of malignancy. Because, like I said earlier, malignant cells really have a very rapid mitotic function. They just divide and divide and divide. That's why they get bigger. very fast. And when they get big very fast, the body can't contain them anymore. And when the body can't contain them, they will eventually saturate the nutrient supply in the area. Meaning, even though they make their own blood vessels to feed themselves, they will not be sustained. They will not be satisfied with that. They will go to areas where there is great blood flow to your lungs, to your brain, to your liver. That's what happens in metastasis. They are looking for greener pastures. They are looking for more nutrient-rich na areas because the mass really rapidly grows, meaning the blood flow, the nutrients cannot cope up with the mass. That's why there are areas na makamatay ang cells. So, what happens? These malignant cells will mutate further so that they can go to other places. Okay? So when you look at a tumor that is very aggressive, that's already metastasized to other parts of the body, and when you see upon microscopically, you can see that the cell itself is like of an immature cell. Dako ang nucleus, gamay ang cytoplasm, chromatin is all over the place. Kato. So, morphologic changes of malignant cells. So, we have pleomorphism, meaning there is variation in size to shape because, like I said earlier, after division, wala pa nakapahuway itong cell, nag-divide na po sila. They don't have time to orient their organelles, to orient their nucleus, to orient anything to a functional state, to a normal or physiologic state. They just divide na po and then they divide. That's why wala nagkadimao ilahang nucleus and their cytoplasm. So there is an abnormal nuclear morphology. So there is a nuclear to cytoplasm ratio of 1:1. Ang normal nato is 1:4 to 1:6, meaning the nucleus should be small compared to your cytoplasm. Why is it big? Because remember, in mitosis, your remember, going back to the genetic to the dogma, to the central dogma. So the DNA is just like a thread of nucleic acid, no? Wala, thread lang na siya. Taas kaya na siya nahilo. And this thread is wound in a spool called our histones. They are compact. So, if it is not used, it is, of course, spun around the histones. But if it is needed, or there is protein synthesis to be done, it unwounds so that there will be transcription, so that the mRNA will see and then mag-transcribe og mRNA, no? And then eventually the mRNA will be translated and then there will be, of course, protein synthesis, no? So if the cell, just a chill cell, no, mature cell siya, and it doesn't need to do a lot of proteins because of course it reached its maximum function na, like in your going back to your skin again, doesn't need to do anything, it just needs to protect, it just needs to be there, it just needs to be flat and keratinized, doesn't do much, it doesn't need to mitosis, it just does what it needs to do. But the nucleus in the stratified squamous, the more mature cells, it's either very small or even none at all. But if you look in the less mature na part nila, dagko pa ilahang mga nucleus because there is lots of protein synthesis, there is lots of preparation for mitosis, diba? Because the stem cell rather, sorry, dili the germ cell to akong ginaingon. The stem cells of your skin, the stem cells of your skin, they need to prepare for mitosis. That's why they need lots of proteins. That's why their nucleus is enlarged because their DNA is unwound. Their DNA is unspun. So remember that your DNA plus your histones is your chromatin. So your heterochromatin is the chill chromatin, that's the compact one, while your unspun chromatin is your euchromatin. If it's compact, it can be stained, and when there is stain, it can be easily colored. So think of cotton candy. If you spread cotton candy together, of course it's gonna be a lighter color, but if you compact it, it's gonna be a darker color. Same with the nucleus. So, and if you spread your cotton candy, the surface area will be bigger, but if you compact it, it's gonna be smaller. Same with your nucleus. If the nucleus, if the cell is mitotically active, giat kaya siya, think the nucleus is expected to be large. And like I said earlier, pag large siya, then, and if we see a specimen that has a large nucleus and then light staining pa jud, then we can say that it's mitotic. It can be either cellularly active as a cell or mitotically active. So mitosis. So the another one is mitosis, indicative of rapid cell growth. So of course malignancy, loss of polarity, anarchic and disorganized. Kay katulagi sige lang siya divide and divide. Wala nagkadimao, no? Wala siya kadimao. So others ischemic necrosis. Like I said earlier, if grabe kay mo divide ang cells, di na makaapos imuhang nutrients and imuhang resources, some of the cells will eventually die because they don't have nutrition anymore because of its own need to divide. So, okay. Next. So, going back, metaplasia is replacement of one cell type to another, and dysplasia is disordered growth. So, both dysplasia and metaplasia may be a precursor to a malignant transformation, but not most of the time. But not all the time. Remember, metaplasia and dysplasia are precursors to malignancy, and we will talk about that later. Here we can see carcinoma in situ, meaning if there is carcinoma in situ, there are already hints of dysplastic changes, but it doesn't breach yet the basement membrane, meaning wala pa siya nag-invade, meaning na-control pa siya in a sense sa body nimo. Diba? Like I said earlier, it's one of the hallmarks katong nakay-breach sa imong basement membrane. So, carcinoma in situ, no? It's already dysplastic na imong cells, but it doesn't still breach. But if it breaches na, it's already carcinoma na. Okay? Metastasis, spread of tumor to sites that are physically discontinuous with the primary tumor. Equivocally, there is no benign tumor that is there are some cases I remember, but we'll not talk of that na lang na case. But remember that if the mass is malignant, if the mass is metastatic, very high chance na malignant yun na siya. So, correlates with lack of differentiation, like I said earlier, aggressive local invasion. This aggressive local invasion is when it already breaches through the basement membrane, rapid growth, and large size. So, we have pathways for metastasis. We have our direct seeding, sample sa peritoneal cavity nimo. And then we have lymphatic spread. This is the most common pathway. What happens, like I said earlier, when your tumor cells develop the ability to metastasize, to ride on the lymphatics. So it's the most common for carcinomas. But for your sarcomas, it's typical with hematogenous spread, meaning it doesn't pass through the lymph vessels, rather the vascular sa mga venous o sa mga capillaries di siya moagi ang imong sarcomas, no. So here is your all right, no. This is our first look sa mga malignant cells. Dili ka siya nice. So if you're gonna look at this is a liver. The liver is one of the most common areas for metastasis because, like I said, daghan siya og blood vessels ug tanang the portal circulation is rich in nutrients from the food you eat. So kung ako tumor cell na lang maong gani, kung cancer na lang maong gani, kumato ta dito sa daghang pagkaon, sa lamion na dugo. So that's why there are the tumor cells have a predilection for your liver. So we have types. This is the uterus. We have a leiomyoma. Benign lang na siya, leiomyoma. Just mga myoma, they can be quite big, but it's benign. But it doesn't mean it doesn't hurt and it doesn't disrupt the surrounding area, but it's benign, meaning it will only stay in the myometrium. Unlike your leiomyosarcoma, it may progress and affect your ovaries, the vagina, other organs. So here we have your benign. Like I said, the benign mass only still grows. It is still a neoplasm, but it is progressive, meaning kaya siya apason sa imuhang body, kaya siya i-hold down. And then there is most probably absent ang imuhang mga benign masses. So everything opposite sa benign is your malignant. So epidemiology, the most common malignancies. Like I said earlier, we will not delve. Of course, nadyo mga noted na mga factors that will cause malignancy. Example, your squamous cell carcinoma, of course, UV light, then lung cancer, smoking, sa pati bladder cancer, smoking po na, alcohol consumption, diet, obesity. What happens when you're obese means there is also a disruption in your hormones, especially in women. If women are obese, there are times that there's an abundance of this estrogen and it will make the endometrium become thicker. And then what happens there is when it becomes thicker, it's a fertile ground for malignancy. Anything that will promote a change in the norm, either metaplasia, dysplasia, can lead to malignancy. Once madaot na imuhang DNA, once you force it to adapt or to change or to get damaged, it's already a risk factor for cancer. So being alive is a risk factor for cancer, no? Everybody, if we were all immortal, eventually everybody will have cancer. It's that inevitable because the DNA is very fragile. Though we have a lot of defenses, at the end of the day, it just needs a good enough mix for it to snowball into effect. So this occurs later, in the later years of life. Like I said, because damage to the DNA, we will talk about that later na lang. So, acquired predisposing factors, chronic inflammation, precursor lesions, immunodeficiency site. So, precursor lesions, they are from either chronic inflammation by the presence of metaplasia, Barrett esophagus. What happens in your Barrett esophagus is when you have reflux of acid from your stomach going up, no, going up your esophagus into the stratified squamous area. What will happen is the stratified squamous of your esophagus, the area in which there is a stratified squamous, the stratified squamous epithelia is not well equipped with handling acid. So they develop into an intestinal mucosa. What happens with this intestinal mucosa is that they have mucin secretions to counteract the acid. That's your Barrett's esophagus. In reverse, we have squamous metaplasia of the bronchial mucosa because when you smoke, there are a lot of the lining of your airways in your mucosa is columnar, and then they have lots of secretions, diba, sa imuhang lungs, so that to trap the bang abog, ana. But due to the fact that smoking is very corrosive and harsh kayo sa lining, the columnar lining of your airways cannot cope with the toxins of the smoke. That's why it 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 makes itself like gahi kayo. So it needs to be stratified squamous because it is more equipped to handle the toxins of the smoke. But no, so when you force this, no, when you force these changes in these metaplastic changes, what you're doing actually is you're forcing the DNA to write something to produce proteins which are not inherently normal. And this process of forcing the DNA to do other things may lead to damage in the DNA itself. And when there is subsequent damage, there is a snowballing effect. Gamay siya din and then eventually it gets bigger due to the accumulated damage. Then we're gonna have a problem. And that problem is cancer. So anything that makes your DNA, that forces your DNA to do one thing instead of another, leading to DNA damage, accumulated DNA damage, there is a chance that it will become a malignant gene. No? We will talk about that later. But so, squamous metaplasia of the bladder mucosa in response to your schistosoma, colonic metaplasia of the stomach in the setting of atrophic gastritis, and the mitral hyperplasia, like I said earlier, sustained estrogenic stimulation, leukoplakia, thickening of the squamous epithelia that may occur in the oral cavity or on the penis and vulva, give rise to squamous carcinoma. Immunodeficient states. So, this is the molecular basis of cancer. Sa book na akong ginakuhaan Robbins, Neoplasia is 100 pages. And most of the topics there are very alien to me at first. So, but I digress, no? Sa una, nag-lisod ko tuon but eventually I fell in love with it. I really like this topic. But my approach with it is you really need to have a solid concept, a solid basic knowledge, and why cancer happens to begin with. What's the point? Why is there even cancer? So, why is there even cancer? So, I will start with my promised explanation. The genome, in which I mean the DNA sequences that eventually lead to protein synthesis, that eventually lead to cellular the dictation of what cellular processes and morphology is a very fragile blueprint of what we are. It's really amazing at the same time, and praise God, maayo kayo na bioengineer ang Ginoo. There are lots of repairs. There are lots of repairs, and there are a lot of course, repair and backup redundancy ng mga sequences in the genome. But about since nagkadaghan man jud tao sa kalibutan, daghan pug sets of genes, no, there are about 1 trillion cells in your bodies containing each individual copy of your entire genome. Taas kayo entire genome nimo kana to sequence na tanang chromosomes nimo, mao na siya diha. There is bound to be some damage there, no, because sometimes we cannot control it. What happens, we have two types of genes, no, think of it as there is an oncogene. An oncogene is not necessarily a cancer cell, no. Onco meaning oncology, di ba? Cancer. Oncogene, kani siya na gene, chill lang ni siya if it's normal. It doesn't do anything, just functions like most of the time. Oncogenes are the ones that say, go, pwede ta mitosis, no? They are the ones that say that, and then they're just chill. But if there is continual DNA damage in that gene, no, the gene is continually damaged, magka-gain of function siya. Instead na mag-go siya every 1 hour, go, pwede ta mag-divide for mag-mitosis. May tabo niya, magka-turbo siya. Instead of every hour, it will become every 40 minutes. And then sa next na pud niya, magkasamot man na. Because gene damage is an accumulation. And if it accumulates, it becomes more and more progressive. So, and then after 40 minutes, and then we have this tumor suppressing genes pod. Uy, nabantayan niya. Uy, every 40 minutes naman na siya nag-divide. Kaning cell, kaning na gene. So, it tries not to repair. So, if na-repair, and then the next time na mag-divide na siya, nibalik na every hour na po siya ka-divide, very good. But, instead na 40 minutes, nahimo namang 30 minutes, nag-divide na po siya. So, hatagan na po natong time, mag-stop sa tag-mitosis, and then it tries not to repair. It's called, so kato, hatagan sa time, mag-heal. Kaya i-repair man dyan na siya, naman tayo mga enzymes, of course, natay mga mechanisms to repair the gene. Yeah, kato. So, kung wala jud gyapon, ano siya, atay pre, instead na 30 minutes to ganiya, nahimo namang every 10 minutes na hinuon siya trial na po nila pa mitosis. Instead na 30 minutes to siya, nahimo namang 20 minutes. Eventually, your tumor suppressor genes, no? So you have your proto-oncogenes, like your oncogenes, proto-oncogenes, and then your tumor suppressor genes. Katong proto-oncogene na akong ginamin ganiya, katong nagpa-start and go sa mitosis, and your tumor suppressing genes are the ones that try to stop if na ay mga problems, no? Na ay problems sa division. Nabantayan mo sa imong tumor suppressor gene na, atay part, sige na lang man siya divide. So, what the tumor suppressor gene will do is it will force, eventually, if worse comes to worse, di na kaya ma-repair, it will force apoptosis. So, force na lang may apoptosis para dili na ma-spread ang gene. Because remember, if one cell is defective and it undergoes mitosis, then you have 2 defective cells, no? And then if those 2 divide, it dili ba na may mong 3, it will become 4 defective cells because it's an exponential type of division, your mitosis, no? Kato. So, divide siya na. And then what happens is, so if you have a problem, you have a gain of function in your proto-oncogene, mahimo na siyang oncogene. And then if you have another subsequently loss of function in your tumor suppressor genes, diya na ta magka-problema pod, no? Because there is no counterbalance. Even normal cells, if there is no tumor suppressing genes, di nila mabantayan na nagkalihis na jud ay ilahang dalan unya sige na sila divide kay wala may tumor suppressor gene, eventually mahimo na nagyapon to siya malignant. Gets? If there is loss of function in your tumor suppressor genes, there is no counter check in your mitosis. So, yun. So the tumor, meaning clonal expansion of a single precursor cell. So proto-oncogenes, there is a gain of function, sigla siya divide. Your proto-oncogenes are the ones that say, go, divide lang. And then your tumor suppressor genes, there is a loss of function, wala na mag-ingon na stop, na tapat, yun na lang nato ng cell na ni. So, your tumor suppressor genes are the ones that regulate apoptosis. And then, if naapoy problema sa imuhang DNA repair ng mga proteins, no, dili na siya makabuhat og DNA repair proteins, of course that's also a problem. Kay even if mag-ingon na imong tumor suppressor gene, hatagan sa nato nig time ni ipa-repair nato siya, nya di magyapon mag-repair, eventually nandiyo maka escape ana mag-mitosis gyapon na siya. So this is what I told you earlier, na this table, normal cell siya. So, na carcinogen-induced mutation. Let's say na gipaon sa siya, sige siya pahayag, no? Igo siya ubilite, no? Naigo siya ubilite, ultraviolet ba? So, then, the stem cell, of course, katuman yun ng gikan stem cell, igo ubilite, na damage iyahang DNA. Instead, ang na-damage sa DNA niya kay katong unsa iyang proto-oncogene, na kay genomic instability. Tapos na kay, so kato, no, sige na siya go, and then na kay precursor mutator phenotype, katong naguba pud imuhang repair, no, kato imuhang DNA repair. So nagka-mutator phenotype, like I said earlier, nagapatong-patong man sila eventually. So there is additional driver mutations founding cell cancers, and additional mutations eventually magka-cancer jud ka. And remember, ang problem sa imong genes kay nagapatong-patong jud na siya. Once mag-start na siya, dili na siya ma-control from the start, dili na siya mapatay, it will eventually lead to cancer. I know it is quite overwhelming, dude. I'm trying my best to explain it. So, tumor progression, pernicious tendency of tumors to become more aggressive over time. Kaya like I said earlier, mag-snowballing man na siya, magka-gain siya dagdag function, mag-evolve man na siya. May tabuan na kay katong mga weak na mga, diba, I told you earlier na yung mga matay na mga tumor cells kay dungod kay dili sila makakuha og mga nutrients. Na uban dia mag-develop gani na mag-metastasize, hindi sila mas nutrition filled na area, so katong mabot sila dito. And then epigenetic alterations, we have DNA methylation, histone modification. So these are your cancer hallmarks, no? So fading growth suppressors kato, di ba? Yung mga tumor suppressor genes, so enabling replicative immortality. This part is very interesting because your tumor cells, na sila telomerases, no? Your telomeres are the ones that inhibit, they are the ones that inhibit divisions among chromatins in a normal cell, because we are all meant to die, no? Sooner or later, mangita na imuhang lawas og ways para mamatay ka. That is the truth. But that's the normal, no? But if that's your normal cells, but your tumor cells, no? Tumor cells they don't have these limitations, no? They just repair their pangit na DNA, and then they're pangit na DNA, they just repair, ay kanang not necessarily repair it, they just replenish it with more mutations. Hantod sa, it will only continually divide if the nutrition, if katuyang resources is adequate. No? So, tumor promoting inflammation, activating invasion and metastasis, lagi katong mangita siya better area, genomic instability, inducing angiogenesis. This angiogenesis just means that your tumor is making blood vessels of its own so that it will have its own nutrition. Resisting cell death, diba? Kay it will resist your apoptosis, no? Because tapos kato deregulating cellular genetics, sustaining proliferative signal, kato sige lang siya dagan, avoiding immune destruction. This resisting cell death, at the end of the day, your tumor cell just wants to live, no? But remember what a cell is, no? A cell is the functional unit of life, diba? In itself, it's alive. The cell is also alive. It has functions. But we need to remember that the cell is still just a unit, no? It is part of something bigger. It needs to do its function so that the greater picture, the organism, will survive. If the cell just says, "Bala na, wa ko'y labot, I just live on my own," no? And then just starts to divide on its own, it forgoes its function na to protect or to absorb nutrients or to produce hormones. It just forgoes that and sige lang siya divide because it wants to survive on its own, because it didn't follow the rules of the genetic blueprint. Wala na siya nag-follow. So, eventually, it will survive, it will grow, but eventually the organism will die. And the tumor cell will also die. So, it's just a lost cause. And at the heart of it, cancer is just selfishness on a cellular level, no? Because it just wants to live, but it doesn't care about others. It only thinks of itself. We must avoid being the cancers of society. So kato. So if you have questions, just PM me, and you know me man, I'm cool lang. Sige. Thank you. Good night. Sorry taas akong lecture. God bless.